Hello Algebra 2, this is day 5 in Unit 9 and we are solving exponential and logarithmic equations. This is our first day of solving. We'll solve again tomorrow. First we'll start by solving logarithmic equations with a log on one side. And the very first thing you want to do is to isolate the logarithm. And then you can either rewrite the logarithm as an exponential equation, or you can exponentiate both sides. So we'll look at those two choices in our first example. In the first example, we could look at our base, log base 2, and decide to choose that base for an exponential. So that we raise 2 to the log base 2 of x, and we raise 2 to the 5th. And 2 to the log base 2, well, that's going to cancel, leaving us x is equal to 2 to the 5th, which is 32. Similarly, we could solve this by rewriting. So if I had log base 2 of x equals 5, I could think of the exponential equivalent, which is base of 2 to the exponent 5 is equal to x, and I still get x equals 32. So whichever way works better for you, you can choose. In number 2, our log is not isolated yet, so we need to isolate it first. First we get rid of this 8, so subtract that, and bring everything else down. To get rid of the negative 2, we need to divide. And our logarithm is isolated. Next, you could either exponentiate or you could rewrite. So I'm going to rewrite. My base is 5. My exponent is 2. And that's equal to negative 4x plus 33. So I simplify and subtract to isolate my x. So negative 8 equals negative 4x, and x is going to equal 2. Okay, in the next problem it looks a little bit different. We have log base 5 of 5 to the 2x plus 7. So some people will realize right away log base 5 of 5 is going to cancel out and leave you with only the exponent. Some people would prefer to rewrite this as an exponential before they get started. So their base is 5 and the exponent is x. So we have 5 to the x equals 5 to the 2x plus 7. And now that your bases are the same, you know that your exponents are the same. So you can just write that x is equal to 2x plus 7, and you can get your x's together. So if negative x equals 7, you can multiply both sides by negative 1 or divide both sides by negative 1, and that you get x is equal to negative 7. Okay, so that was pretty quick. We're going to go on to the next page. In the next page, we're going to solve logarithmic equations. So to solve an equation with the logarithm of the same base on both sides, you want to exponentiate both sides. But you have to be sure to check for extraneous solutions. Those will pop up a lot when we have a logarithm on both sides. So if we raise 7 to the left side and we raise 7 to the right side, then these will cancel out, and we're left with a simple quadratic equation, x squared minus 5x equals 6, and it's good to see if it's going to factor. So let's move everything to one side, and it does factor. So we have x minus 6 times x plus 1 equals 0. And we have two solutions, x equals 6 and x equals negative 1. But you have to check for extraneous solutions. So remember that what is inside the logarithm cannot equal 0. Now, of course, the 6 is never going to equal 0, so that's not a problem. And also, it cannot be less than 0. So let's look at, on the left side here, x squared minus 5x. We want this to be a positive number. So I'm going to put 6 into x squared minus x. If I do 6 squared minus 5x, that'd be 5 times 6. I get a positive 6, so that's okay. And then I'll do the square of negative 1 minus 5 times negative 1. And that's going to give me 1 plus 5. And that's also 6, so that's also okay. So both answers work this time. I'll put a box around both of them. But if either of those made what was inside the parentheses negative, I would cancel that one out as an extraneous solution. Okay, so we're moving on to solving exponential equations. And one strategy to solve an exponential equation is to try to write each side as a power of a same base. That won't always work for you, but today it's going to work. So we have 3 to the x plus 2 is equal to 81. And I think to myself, oh, 81, that can be a power of 3. So I'm going to rewrite that. So I have 3 to the x plus 2 is equal to 3 to the 4th. Now my bases are the same, so my exponents must also be the same. So x plus 2 has to equal 4. And you can solve that and you get x equals 2. The next problem is similar, but this time we're ending up with a number in our denominator. So let's get that number out of the denominator. We have 5 to the 2x minus 1 on the left, and on the right I have 1 over 5 to the third. So remember from your exponent rules, 1 over 5 to the third is equal to 5 to the negative 3, and now we have the same base. So now I can set 2x minus 1 equal to negative 3, 2x equals negative 2, and x equals negative 1. Alright, that's the end of page 2, and we'll move on to our next video for page 3.